but he noted that the effect is considerably increased by the use of phosphorescent bodies, such as yttrium, uranium glass, etc. Here Tesla lays the foundation for fluorescent lighting. Applied to such lamps were currents at potentials ranging from a lower limit of 20,000 volts up to voltages in the millions and vibrations of 15,000 cycles per second and up. Tesla dreamed of creating what he called pure light or cold light by generating electric vibrations at frequencies that equaled those of visible light itself. Light produced by this direct and efficient means would require vibrations of 350 to 750 billion cycles, but Tesla believed such oscillations, far above those attainable by his coils, would someday be achieved. Even so, his rarefied gas tube lamps produced a light that more closely approximated natural daylight than any other artificial source. Tesla's light is like the full-spectrum light that is coming to be recognized as far more healthful than Edison incandescent and particularly more healthful than conventional fluorescent. Full-spectrum lighting is believed by some health practitioners actually to have healing properties. No sudden burnout. Tesla's gas tube lamps burn indefinitely, as do today's neon tubes, for there is nothing within to be consumed. Tesla's lamps that contain electrodes like carbon rods, however, do undergo some deterioration. In Tesla's words, a very slow destruction and gradual diminution in size always occurs, as in incandescent filaments, but there is no possibility of sudden and premature disabling which occurs in the latter by the breaking of the filament, especially when incandescent bodies are in the shape of blocks. In vacuum lamps, the life of the bulb depends upon the degree of exhaustion, which can never be made perfect. Also, the higher the frequency applied to such a lamp, the slower the deterioration. Electrodes glow at high temperatures, and this raises the problem of how to conduct energy to them, since wires or other metallic elements will melt. The problem must be addressed in lamp design. For example, in the incandescent lamp shown at the opening of this chapter, the lead-in wires connect to the hot electrodes via bronze powder contained in a refractory cup. Tesla may have designed his capacitor-based bulbs to help address this same problem. High heat. Tesla's search for the ideal electrode is reminiscent of Edison's search for the long-lasting filament. The production of a small electrode capable of withstanding enormous temperatures, said Tesla, he regarded as the greatest importance in the manufacture of light. One of the electrodes he tried was a small button of carbon, which he placed in a near vacuum. Tesla regarded the high incandescence of the button to be a necessary evil. For lighting purposes, it was the incandescence of the gas remaining in the mostly evacuated chamber that was important. But the carbon button lamp proved to have some remarkable properties beyond its use for illumination. When the voltage was turned up, the lamp produced such tremendous heat that the carbon button rapidly vaporized. Tesla experimented extensively with this fascinating phenomenon. For the button of carbon he substituted zirconium, the most refractory substance available at the time. It fused instantly. Even rubies vaporized. Diamonds, and, to a greater degree, carborundum, endured the best. But these could also be vaporized at high potentials. Tesla worked on the problem of heating. I have read that he contributed to the development of a high-frequency induction heating. Did Tesla work on the problem of space heating? Certainly the huge current draw of conventional electric heaters, which use resistive elements, argues for some inventiveness in this area. Tesla did observe that the discharges from a Tesla coil resembled flames escaping under pressure and were indeed hot. He reflected that a similar process must take place in the ordinary flame, that this might be an electric phenomenon. He said that electric discharges might be a possible way of producing by other than chemical means a veritable flame which would give light and heat without material consumed. The behavior of the carbon button lamp suggests that a new heating mode might be found in the effects of high-frequency currents in a vacuum. Lighting up the sky. Hold a fluorescent tube near a Tesla coil and it will light up in your hand. This is true of any tube or bulb with vacuum or rarefied gas. A more efficient way is to ground one end of the tube and put a length of wire as a sort of antenna on the other. Better yet, put a coil of wire that resonates with the secondary in series with the tube and ground, and you have the optimal wireless power arrangement. Tesla conducted many experiments with different arrangements like this, using on some occasions the widely available Edison filament incandescent, which lighted up more brilliantly than usual because of the effects of high frequencies on the bulb's rarefied interior. Inside his New York lab, Tesla strung a wire connected to a Tesla coil around the perimeter of the room. Wherever he needed light, he hung a gas tube in the vicinity of this high-frequency conductor. Tesla had a bold fantasy whereby he would use the principle of rarefied gas luminescence to light up the sky at night. High-frequency electric energy would be transmitted, perhaps by an ionizing beam of ultraviolet radiation, into the upper atmosphere, where gases are at relatively low pressure, so that this layer would behave like a luminous tube. Skylighting, he said, would reduce the need for street lighting, and facilitate the movement of ocean-going vessels. The aurora borealis is an electrical phenomenon that works on this principle, the effects of cosmic eruptions such as those from the Sun being the source of electric stimulation. I, for one, am grateful that this particular Tesla fantasy never materialized, since it is difficult enough to see the stars with existing light pollution, and there might be undesirable biological impacts as well. Rotating brush. Tesla took an evacuated incandescent-type lamp globe, suspended within it at dead center a conductive element, stimulated that element with high-voltage currents from an induction coil, and thus created a beam-like emanation, a brush discharge that was so eerily sensitive to disturbances in its environs that it seemed to be endowed with an intelligent life of its own. The device works best if there is no lead-in wire. In the bulb shown, every measure has been taken to construct it so it is free from its own electrical influence. The bulb could be stimulated inductively by applying energy to metal foil wrapped around its neck. Thus excited, an intense phosphorescence then spreads at first over the globe, but soon gives place to a white misty light, observes Tesla. The glow then resolves into a directional brush or beam that will spin around the central element. So responsive is it to any electrostatic or magnetic changes in its vicinity that the approach of an observer at a few paces from the bulb will cause the brush to fly to the opposite side. A small, inch-wide permanent magnet will affect it visibly at a distance of 2 meters, slowing down or accelerating the rotation according to how it is held relatively to the brush. Tesla never patented the rotating brush or used it in any practical application, but he believed it could have practical applications. He saw one use in radio where the device could conceivably be adapted to being a most sensitive detector of disturbances in the medium. The rotating brush appears to be a precursor of the plasma globe toys now in fashion. These are sometimes called Tesla globes. Tesla's new lighting was famous in its time. Tesla, the promoter, saw to it. He conducted demonstrations at lectures before the electric industry associations, before large audiences in rented halls, and before select groups of influential New Yorkers in his Manhattan lab. His articles about the new lighting were published in the popular scientific press and it was reported in the newspapers. Still, it did not catch on with the powers that be, who no doubt saw in it Tesla's perennial pile of scrap problem. But, I wonder, would the whole electric distribution system have to be scrapped to implement the efficiencies of Tesla lighting? Conceivably, the new lighting could be run off of local oscillators at the consumer end, the old power distribution system remaining intact. This is still a possibility, as it has been for about 100 years. 16. Transportation. Tesla speculated that, perhaps the most valuable application of wireless energy, will be the propulsion of the flying machine, which will carry no fuel and be free from any limitations of the present airplanes and dirigibles. The possibility of electric flight intrigued Tesla, though he never did patent an electric aircraft. But he did patent an electric railway using his high-frequency, high-potential electricity in a by-wire mode, and also patented a radical aircraft that, while not electric, did have an advanced power plant, his disk turbine. Tesla's railway and aircraft can be numbered among the lost inventions. The closest transport technology has come to putting any of Tesla into actual practice is with diesel-electric power using Tesla polyphase motors, an early and notable example of which was the ocean liner Normandy. In the field of transport, Tesla is more commonly identified with anti-gravity flight and UFOs. Although this identification is based upon nothing more than a few public utterances, His suggestions charged the imagination with possibilities. High-frequency railway. Tesla's high-frequency, high-potential railway picks up its power inductively without the use of the rolling or sliding contacts used in conventional trolley or third rail systems. A pickup bar travels near a cable carrying the oscillating energy. This cable, which Tesla specifically invented to carry such currents, is the precursor of the grounded shielded cable used today to carry TV and other high-frequency signals. But unlike today's cables, which carry energy only of signal strength and shield by means of a continuous grounded static screen of fine braided copper wire, Tesla's high-voltage cable uses metal pipe or screen that is broken up into short lengths, very much shorter, says Tesla in his patent, than the wavelengths of the current used. This feature reduces loss. Since the shielding must not be interrupted, the short sections are made to overlap but are insulated from one another. To further reduce loss to ground, an inductance of high ohmic resistance or a small capacity is placed in the ground line. Motor mystery. A conundrum raised by Tesla's railway patent is that the vehicle is powered by an electric motor. But nowhere among Tesla's inventions is to be found an electric motor that runs off of high-frequency currents. Was Tesla planning to use a lower frequency here, something under 1000 cycles? Did he have a converter in mind that could bring the frequency down? Or did Tesla invent a high-frequency motor that never made it into patent, an invention that may be among his unpublished notes? Anyway, Tesla proceeds in many of his discussions of high-frequency power as if this problem were solved. I've seen references post-Tesla to the existence of such a motor. Free energy inventor, Herman Plauson, next chapter, refers to high-frequency motors. These motors have magnetic cores made of very thin laminations insulated from each other, a design that would limit damping effects. Turbine aircraft. Tesla's only patented aircraft is a vertical takeoff and landing plane that he intended as an improvement upon the helicopter, already invented at this time, 1921, the helicopter type of flying machine, especially with large inclination angle of the propeller axis to the horizontal, at which it is generally expected to operate, is quite unsuitable for speedy aerial transport. It is incapable of proceeding horizontally along a straight line under prevailing air conditions. It is subject to dangerous plunges and oscillations. And it is almost certainly doomed to destruction in case the motive power gives out. Advances in helicopter design may have mitigated some of these problems, but at least the last one still holds true. Tesla's craft, which has a large wing area, is powered by two disc turbines, rotating in opposite directions. The engineering problem of swinging the pilot and passengers around 90 degrees after takeoff is solved at least to Tesla's satisfaction. There have been some experimental vehicles but nothing in production. Electric flight. Tesla's dream electric aircraft would be powered by means of magnifying transmitters. Aerial machines will be propelled around the Earth without a stop. Also, in 1900, he predicted a cold coal battery with such output that a practical flying machine would be possible. Such a battery also would enormously enhance the introduction of the automobile. Tesla fantasized a personal aerial taxi which could be folded into a 6-foot cube, and would weigh under 250 pounds. It can be run through the streets and put in a garage, if desired, just like an automobile. See Tesla's amazing flying machine for more. Explaining how his Earth-resonant wireless power system could energize vehicles aloft, he said, "Power can be readily supplied without ground connection, for, although the flow is confined to Earth, an electromagnetic field is created in the atmosphere surrounding it." Tesla believed such a system to be the ultimate method of man-made flight. With an industrial plant of great capacity, sufficient power can be derived in this manner to propel any kind of aerial machine. This I have always considered the best and permanent solution to the problems of flight. No fuel of any kind will be required as the propulsion will be accomplished by light electric motors operated at great speed. Anti-gravity. Tesla wrote in 1900 of an anti-gravity motor, Imagine a disk of some homogeneous material turned perfectly true and arranged to turn in frictionless bearings on a horizontal shaft above the ground. Now, it is possible that we may learn how to make such a disk rotate continuously and perform work by the force of gravity. To do so, he said, we have only to invent a screen against this force. By such a screen we could prevent this force from acting on one half of the disk, and rotation of the latter would follow. Does it not follow then, that such a gravity screen could also be used to levitate a vehicle? Tesla held no patent on such a device or on any other anti-gravity device, and there are no published notes on experimentation in the area. Nevertheless, Tesla inevitably pops up in the literature of anti-gravity and UFOs. This may be because Tesla was a prominent exponent of a physics in which anti-gravity seems more feasible because gravity is better explained. A researcher theorist of today, Thomas Barton, allows for gravity control in the physics he calls the new Tesla electromagnetic, scalar, standing. Waves in time itself can be produced electrically, and this becomes a magic tool capable of directly affecting and altering anything that exists in time, including gravitational fields, says Barton. In 1931, the editor of Science and Mechanics, Hugo Gernsback, reported, "It is believed by many scientists today that the force of gravitation is merely another manifestation of electromagnetic waves." Edward Farrow, a New York inventor, reported in 1911 an anti-gravity effect produced by a ring of spark gaps. When the gaps were fired, the device, called a condensing dynamo, lost 1/6 of its weight. T. Henry Morey wrote, "Frequencies may be developed which will balance the force of gravity to a point of neutralization." Anti-gravity researcher Richard Lefers Clark places the frequency of gravity's vibrations right at nature's neutral center in the radiant energy spectrum, above radar and below infrared, at LO12 cycles per second. 17. Free energy receiver. For starters, think of this as a solar electric panel. Tesla's invention is very different, but the closest thing to it in conventional technology is in photovoltaic. One radical difference is that conventional solar electric panels consist of a substrate coated with crystalline silicon. The latest use amorphous silicon. Conventional solar panels are expensive, and, whatever the coating, they are manufactured by esoteric processes. But Tesla's solar panel is just a shiny metal plate with a transparent coating of some insulating material, which today could be a spray plastic. Stick one of these antenna-like panels up in the air, the higher the better, and wire it to one side of a capacitor, the other going to a good earth ground. Now the energy from the sun is charging that capacitor. Connect across the capacitor some sort of switching device so that it can be discharged to rhythmic intervals, and you have an electric output. Tesla's patent is telling us that it is that simple to get electric energy. The bigger the area of the insulated plate, the more energy you get. But this is more than a solar panel because it does not necessarily need sunshine to operate. It also produces power at night, of course. This is impossible according to official science. For this reason, you could not get a patent on such an invention today. Many an inventor has learned this the hard way. Tesla had his problems with the patent examiners, but today's free energy inventor has it much tougher. Tesla's free energy receiver was patented in 1901 as an apparatus for the utilization of radiant energy. The patent refers to the sun, as well as other sources of radiant energy, like cosmic rays. That the device works at night is explained in terms of the nighttime availability of cosmic rays. Tesla also refers to the ground as a vast reservoir of negative electricity. Tesla was fascinated by radiant energy and its free energy possibilities. He called the Crookes radiometer, a device which has vanes that spin in a vacuum when exposed to radiant energy, a beautiful invention. He believed that it would become possible to harness energy directly by connecting to the very wheelwork of nature. His free energy receiver is as close as he ever came to such a device in his patented work. But on his 76th birthday at the Ritual press conference, Tesla, who was without the financial wherewithal to patent but went on inventing in his head, announced a cosmic ray motor. When asked if it was more powerful than the Crookes radiometer, he answered, "Thousands of times more powerful." How it works: from the electric potential that exists between the elevated plate, plus, and the ground, minus, energy builds in the capacitor, and, after a suitable time interval, the accumulated energy will manifest itself in a powerful discharge which can do work. The capacitor, says Tesla, should be of considerable electrostatic capacity and its dielectric made of the best quality mica, for it has to withstand potentials that could rupture a weaker dielectric. Tesla gives various options for the switching device. One is a rotary switch that resembles a Tesla circuit controller. Another is an electrostatic device consisting of two very light, membranous conductors suspended in a vacuum. These sense the energy buildup in the capacitor, one going positive, the other negative, and, at a certain charge level, are attracted, touch, and thus fire the capacitor. Tesla also mentions another switching device consisting of a minute air gap or weak dielectric film, which breaks down suddenly when a certain potential is reached. The above is about all the technical detail you get in the patent. Clausen's converter. Tesla's invention may have helped to inspire the many other inventors who have worked in the field of free energy. At least a dozen are on record. Let's look at one in particular. In 1921, Hermann Clausen, a German experimenter, succeeded in obtaining patents, including one in the U.S. for conversion of atmospheric electric energy. In school, every introduction to electricity touches on the phenomenon of so-called static, or electrostatic, electricity, and this is what Clausen means by atmospheric. Static electricity is built-up charge, electricity in a raw state, and it comes easy in nature, as evidenced by lightning and the aurora borealis. If you have ever seen a frictional static machine in operation, it's not difficult to imagine the tremendous potential in artificially produced static. A rotating disc, type of static machine, or the silk belt type, as in the Van de Graaff generator, produces discharges like those from a Tesla coil. Unfortunately, in school, the subject of static electricity is briefly touched upon and then abruptly dropped, never to be mentioned again. Electrical power sources thereafter are limited to the battery or the wall socket. How it works. In the Clausen drawing, the free energy converter on the left interfaces with a disc-type static machine via special pickup combs. When the static collecting disc is rotated, the combs pick up the charge, one comb going positive, and the other negative. The combs, in turn, charge up their respective capacitors until sufficiently high potential builds to jump the spark gap. The oscillatory discharge is induced into the transformer primary. This is high voltage, high-frequency electric energy. The familiar spark gap oscillator has turned charge into dynamic energy. The transformer steps down the vibrating high voltage to practical levels to power lighting, heating, and special high-frequency motors. The Clausen patent drawing shows a device that works on the same principle but collects energy by means of an antenna, as does Tesla's receiver. Since the higher the antenna the better, and the more area the better, Clausen favors big metallic helium balloons. Clausen says the safety gap, which has 3 times the resistance of the working gap, is absolutely necessary for collecting large quantities of charge. The capacitors across the gaps in the series safety gap allow for uniform sparking. Clausen's device suggests that Tesla's might be explained in terms of electrostatics. Tesla, at the press conference honoring his 77th birthday in 1933, declared that electric power was everywhere present in unlimited quantities and could drive the world's machinery without the need of coal, oil, gas, or any other fuels. A reporter asked if the sudden introduction of his principle wouldn't upset the present economic system. Tesla replied, "It is badly upset already." Now that is abstract thinking. There is no telling where we would be today, had Tesla been funded fully during his heyday. I also believe that some of his discoveries may be useful in paranormal research.